All right, so week 9, NRGY 213. I don't know how many hits these videos get, but apparently my wife checked one out and said that I look like this half the time with my head sticking out. So,
You got it for it?
gosh. All right, there I am. My whole face is right at the screen. Well, I think she managed to get me somewhat color coordinated today. I got at least a dark jacket on, a dark shirt, but
I think you'd be all right, Brad.
I think I'll make it. Thanks, Ryan. Okay, so you guys just want to dip into learning unit 8 then? Does that sound good for everybody?
Yeah, sure.
Okay.
Let's look it up somewhere.
All right, let's look into it. All right. So here we go. Smaller components, electrical circuits. And one way to think about this is just like the stuff we've been doing up to now is mainly like the muscles in your body, and this stuff's more the brains, right? So both have to be functioning for the whole system or organism to work. And once we start to get into, your smart grid, these are going to become even more important. When do things turn on? When do they turn off? So switches, that's just on-off. Give me an example of a sensor. What might you sense in order to make a switch decision? Might sense heat, right? So in your hot water heater, it gets too hot, you shut it off. House gets too hot, you might shut your AC on. Might sense pressure. Might sense motion. A lot of these, rooms have motion detectors. Turn the lights on, you leave, then they got a timer. RPM, so you don't burn your motor out if it's going too fast. So just control circuits. Relays. What do you guys think of when you hear relay?
Cars.
Yeah.
Basically, using smaller voltage to control something larger.
Yeah. Relays. Sometimes you think of like a solenoid too, like a bigger switch. So you've got one little tiny voltage that triggers a larger one. Same thing like with a transistor. All right. And there you go. Control the temperature on the radiator, the water temperature. Okay, so we're in Petrozula, chapter 4. So let's just look at questions 3 and 6, page 66. All right, so the first question 3, it says, what do the terms normally open and normally close refer to when used in defining the switching action of a push-button switch? Sounds fairly straightforward. Let's go see where push buttons are. So there's drum switches, selector switch, pilot switch. There's a picture of a push button there, figure 4.5. So 4.5 starts on page 62. All right, so if you just if you read the whole thing, I'm just going to read right out of the book. The normally closed maintains contacts of the emergency stop button will open when the push button is pressed and remain open until it is manually reset. It says, since emergency stop contacts are held open by the push button operator mechanism, what's that? Well, it's a spring. It's just a spring holding it open. The motor will not operate if the start button is pressed. In order to restart the motor after the emergency stop button has been activated, you must first reset the emergency stop button and press the start button. And, yeah, so I'm just going to hold this little guy up. And here's a really good example, right in the book. I'm just looking at figure 4.8. And really good example of that is your pilot light on your water tank. So normally, that thing is open and not running. You close it, and when you close it, that allows gas to flow, but only when you're holding the button down. So I don't know if you ever restarted a hot water heater, but you hold the button down. Two things have to happen. So it's a little bit like a logic circuit. You have to be holding the button in so gas is flowing, and the temperature sensor in there has to be hot enough to know that the pilot's actually on. If both of those two logic things aren't happening, the gas stops flowing to result in a safer situation. So, and and mechanically, it's not shown in this book, but mechanically, right in here, there's going to be a little spring holding that thing open. All right, so that's question 3. Oh, here's the top of my head now. See the top of my head?
It's college lecture.
All right, so the next one is compare the operation of momentary and maintained push-button operators. Momentary and maintained. I think I might be able to just go back in here.
So on page 62,
Yep.
this is on figure 4.4.
Yep.
This kind of has the same thing. You hit the start button.
Oh, there you go,
But
yep.
there's also a jog button. That's your difference in those two. You have a momentary, which is a jog, like you're jogging the conveyor belt because you're looking at it or working on it.
Mm-hmm.
And then your start is the continual running or maintained, because once you start a conveyor, it serves a purpose to move something, so you want it to keep moving. So,
On a start one, would you, or a momentary, would you have to keep the button pushed down?
Yeah, you would. It's
Yeah,
just,
like
well, it's,
your car.
yeah, in your car, so your start button is your momentary, and as long as you're holding that ignition turn, it's gonna be engaging your starter motor. You don't want that thing running while the car's running, so that's your momentary. And then, well, essentially, your ignition in the on position is your maintained.
Right. Well, you mentioned the conveyor belt. I know I've worked on a conveyor belt too. A lot of times, like you're saying, momentary when you gotta keep that button.
yeah, when you're holding it to like,
It'll stop you and let it out.
yeah,
Yep.
that's exactly what a momentary is in this concept.
And that momentary is gonna be normally open,
Okay.
more or less.
Yeah, you're basically your maintenance conveyor belt momentary switch is what is the difference, the start versus that.
There we go. All right, so that's pretty straightforward. So questions 3 and 4 on page 70. These are review questions on page 70. So 3, control application calls for an NC, held open limit switch. What kind of connection does this imply? Control applications calls for an NC, held open limit switch. What type of connection does this imply? I feel like Alex Trebek on Jeopardy. I'll take switches for.
Just don't try self insurance. Again.
So let's move on. I'm just going to go with what kind of connection is it? Well, it's a normally closed connection. It might just be asking you what I don't see any other connection types. I went back here, I went to connection diagrams. And there's just a little blurb about it on page 35. It says connection diagrams can be found on the nameplate of some motors. And what you're gonna see on that nameplate are gonna be these little diagrams like we're seeing in 414. And it's gonna tell you whether these things are normally open or normally closed, so I would go with that. I don't see any other formal definition for what a connection is. I mean, the switch itself is the connector. It's completing the circuit.
Well, the traditional, it says here, what, are you on number 6?
I was still on number 3.
Oh, it's still on number 3.
I was still on number 3 on page 70. So I would just go with a normally closed connection. Okay, so now let's look at, and then question 4, I think we already answered that. What are the 4 common types of limit switch operator heads? And those are all given right there on page 67. So you've got a lever type. That's actually shown in figure 415. The adjustable lever, well, I might as well draw that. So you've got a lever, and right, so you just got something doing this. The next one is an adjustable lever. Why might you have an adjustable lever?
Well, it all depends on, you would have an adjustable lever to tell you when it needs to kick something on to refill. You would have an adjustable lever for sensing how much gasoline's in the gas tank.
Yeah, it's, yeah, I think it's so that, it could also be if your machine is wearing out, you could make it more or less sensitive too. So you could take this pivot and move it back and forth. So here's the end that you push up and down. This is the other end that might make contact. So this might be your contact down here.
That's an adjustable lever?
There's your adjustable lever. It's kind of sitting there in the middle of.
Yeah, I see that, but
Well,
from my experience, that's, the reason it's adjustable is because pre-existing bolt holes
okay.
aren't the same where they need to be for, say, lever number 1.
Oh, right on. Okay. Yeah.
And so you can adjust that, to whatever height you need. All I see is one rubber coating lever on handle on it.
Well, that's right. It's still going to have one handle.
So basically, it's just, you got something moving. These switches are for traditional limit switches.
Yep. Yep.
And that means something, well, as the diagram shows, diagram 413,
Mm-hmm.
you got something moving forward and backwards. It's usually operated by, forward, backward, and a stop. Well, you don't really need a stop on it, but
Right.
usually they have them for emergencies.
Right.
Where the micro is just, it just stops it. It'll hit, something will hit it and it stops.
Okay, so that's your adjustable lever. The
Yeah,
fork.
that's the one I'm going to adjust. The other ones
Yeah.
work fine, it's just that these adjustable ones I see from experience, they work really well with pre-existing, threaded holes that you gotta use, so you can raise it, lower the level of it.
Mhm.
And like say maybe equipment gets old, you might have to change some things around.
Yeah. I'm not that familiar with the fork lever. Have you seen? I'm looking at it here, but I'm not seeing it in an application.
It travels in 2 directions, you've got the mechanical bed that automatically alters back and forth. So imagine it'd trip it the forward way, and then once it would come back to normal, it'd stop, and then, back you go.
You would use this on a crane.
Yeah, like
So it limit
Okay.
each way, anything that spins this
a
way.
trolley.
So anything that, like your
Gets out of-
robotic arm that you have.
Gets out of bounds too far to
Yes.
left or right,
Yeah.
is gonna shut her off.
So all of your arms for any type of robotics would have that.
Yeah, makes sense.
It would either break its own pivot point without it,
Right,
because it's a limit each way
okay.
for every.
Oh, I like that. Yeah, we were actually designing something similar to that. I might as well just show this guy. We've been trying to, and this isn't so much a switch, but a power system, where if you had a inverted pendulum, this is more of an energy system, but let's say you've got an inverted pendulum with a magnetic head on it, and you want to take this guy and make electricity with a generator. And what we're thinking about doing is having a metal truck, whatever.
What makes a Lamborghini?
That looks like a Dr. Seuss car, I don't know. Anyway, so when the car's approaching, the thing swings to the right. You're going to want to stop over there on it. Once the car's over here, it's going to swing to the left, and you're going to want some stop over there. So similar concept, but I like the crane idea, the robotic arm. It's just keeping it from going out of bounds because you wouldn't want this thing to swing too far. Okay, and then the wobble stick. Use an application that required detection of a moving object from any direction rather than in one or two directions along a single plane. That's a good example of that one. Wobble stick switch. Hey, what's going on, Corey?
Oh, yeah, so your package going through a conveyor belt, that lets the whole conveyor system know that there's a package now on your conveyor belt, so you've got it. So they're long enough to sense different sizes, and
Yeah.
the further it goes up, it tells you what size it is, then it tells the conveyor where to put it.
Right, right. I was even talking, yeah. It could come from, well, on the conveyor belt though, what I'm seeing is it's just going to be one direction, along the belt. I'm wondering if a situation where, I mean, in some sense,
Or not, don't use a conveyor belt, use a production line then.
okay,
So they're all conform to the same size.
uh-huh.
So you're building the same thing, and this wobble stick can count on
Mm-hmm. So the wobble stick's just hanging up top. Every time a package goes by, it gets kicked in that direction. I think another one, I'm just thinking a light bulb from a ceiling. Remember the old school chain that hangs down?
Yeah,
You're
sure.
fumbling around the dark. I mean, you're going to be able to grab that guy from any direction, pull it down.
Interrogation lights.
What's that?
Interrogation lights.
Interrogation lights. But just like you might see in an old closet, I don't think they're code anymore, but just a pull chain, because your hand's waving around, it could be detected from any direction. Wobble stick, wobble chain.
stick.
There we go. And then the fourth one, it says, push roller type. That's not even. Stop. Well, this one, so the push roller would be a one-dimensional. I'm thinking that would be a good example of a conveyor belt where something comes to the end and then stops. Right, so you've got,
So
So-
you're basically talking about a grocery store. conveyor belt comes to the end and stops,
Yeah.
even though it's using a laser, it's the same
Yeah,
thing.
yeah, right. Cool, I love it. So here's your conveyor belt. Is the conveyor belt in the grocery store normally open or normally closed?
Normally closed.
Normally closed.
The laser breaks it.
There we go.
Well, that's, you can design that system either way.
Sure.
It just makes more sense to design.
Normally closed means it's running because the circuit's closed. Here comes your package. Breaks the laser sitting right here. Is the laser, let's think about this. Is the laser sitting right at the,
Sitting at the precipice.
is it sitting right at the end?
Yeah, it's basically set right before it would cause it to fall onto the metal, so it stops it right there. So right before your last roller.
Or is it just the opposite, though? Because as soon as you set something, so I'm wondering if the laser is actually just picking up the whole bed. You set something on there, and that reflects it back.
Well, they turn it on.
Oh, I don't know.
Do they turn on?
That's a good question.
The grocery store conveyor, and then
There's a on switch.
Yeah.
You turn on.
Yeah, they have
It opens up when the lasers, it probably shoots directly across.
Yeah.
Something.
So they.
And then
turn it on.
when it gets to the end, it does turn off, doesn't it? There you go. Yeah, that's right. Because the clerk sees, okay, there's stuff there, hits the foot pedal. Here it comes. So actually, it's actually going to be normally open. Clerk sees it. Sees it. Closes it. Laser sees it. And then opens it up again so it doesn't do it. Okay, well, I like that. And it's a laser instead of a roller, but you could also imagine some, something hanging down here with a wheel on the end. That thing, that little pendulum gets.
Yeah. So it's just an easier way to think of like a commercial conveyor belt.
Yeah, I like it. Okay, I think we got time for one more. Question 2, page 85. Question 2, page 85. So we're on actuators. In what ways are electromagnetic relays employed in motor control systems?